and the second half is similar to what we did with the sum and difference formulas, where you want to evaluate what the sine of 105 is. You could actually break the sine of 105 down into sine of 60 plus 45, because those are special angles, and we can evaluate it that way, and we have evaluated that way. But you could also do a half angle on this and still get a right answer. So when you do the half angle, it'd be the sine of 210 divided by 2. And 210 is also a special angle because it has a reference angle of 30. Okay, so how do you expand that? That's going to be plugging it in to your half angle formula for sine. 1 minus cosine A. Be careful, your A here is 210. This is your A divided by 2. All over 2. And so you have to find out what the cosine of 210 is. Cosine of 210 is down here. Talking about a reference angle of 30 degrees. So the cosine of 210 is equal to a negative cosine of 30 because it's tangent down in that area. Again, being very careful with those negative signs. And so I know that that's equal to a negative radical 3 over 2. So at this point, you can go ahead and substitute in. And I can also think about the positive or negative sign out in front of that radical. The angle here is 105 degrees. That means I'm evaluating what the sine of 105 is. I don't have to think about making it more complicated than what that is. 105, when I draw that, is somewhere in the second quadrant. And so I know that the sign is positive in the second quadrant because of Santa Claus. So that tells me that the sine of 105 is a positive number because it's in the second quadrant. I don't have to think of 210. I know it's 105. It's giving me that angle. So that's straightforward. Therefore, it becomes 1 minus, and then in parentheses, negative radical 3 over 2. Majority of mistakes will be made right with that negative sign inside that parenthesis. At this point, I know that those become positive, and I want to clear out the fraction within a fraction. So under the radical sign, if I multiply by 2 over 2, I'm going to get, let's see, when I distribute that 2 through, this whole thing in parentheses, when I distribute that 2 through, I end up with 2 plus radical 3 as I distribute. And then on the bottom actually becomes radical 4, so I can put that whole thing over 2, not under the radical anymore because radical 4 is 2. And that's my answer for that problem. 2 more problems. Let's take a look at this next one. Number 30 in the back of the section says, graph y equals 2 sine x over 2 quantity squared, and this says graph from 0 to 4 pi. Again, we look at that and we say, well, it's a squared sine. I don't know how to graph that, so I want to use an identity to help me simplify it and then graph it at the end. To convert that to something a little bit easier, I'm going to recognize that it's a half angle formula, and this is going to simplify really nice because you're squaring the radical. So it becomes 2 times, and then the big radical plus or minus 1 minus cosine x over 2 using the identity. And then I'm taking this and I'm actually squaring that whole thing. Well, what happens when you square the positive? It's like a positive 1 out front. Positive 1 squared is 1. Negative 1 squared is negative 1 times negative 1, which is 1. Both of these become positive, so the plus or minus becomes positive, and I don't have to write it. So now you're going to have 2 times, and then in parentheses, 1 minus cosine x over 2, because this radical is really to the 1/2 power. 1/2 times 2 is 1, and therefore it'd be kind of like that. You can think about it. This becomes y equals 1 minus cosine x. That's an easy graph. You're just dealing with a negative cosine, so I'm going to remind myself negative cosine looks like this. And then it's just a shift up 1. So I don't have to really go through and get the amplitude, period, phase shift. I think I'm pretty good at this point. So I'm going to look at this and I'm going to think, okay, negative cosine going to 4 pi. So I'm just going to go pi, 2 pi, 3 pi, and 4 pi. I know one cycle is going to go to 2 pi starting at the bottom, so I know it's going to look like this. And I mean, you could put in little slash marks in there as well, but starting down low and going up high, going down, start doing the same thing because the directions say to go to 4 pi. And so now this graph is going to look like this. And then I'm not done yet because I haven't labeled my axes yet. If I didn't have the 1 here, that would be my graph, but because there's a 1, I have to add 1 to it, which means it's going to be pushed up. So instead of 1 and negative 1, what I really want to do is say this is going to be 0 and this is going to be 2 by adding 1 to those axes. Some of you may want to draw that up, but I'm comfortable if you can show that by adding 1. And this is the same thing as y equals a negative cosine x plus 1. So some of you may see it's a little bit easier that way as well. That takes care of 2 problems, and then we have one more problem to go through, which is a proof. Didn't want to go through the section without some proving. And so this one is a little bit more challenging because really it's hard to see what is on each side. The one side is the cosecant a over 2 quantity squared, and the other one is 2 secant a over secant a minus 1. It's hard for me to understand which direction to go with this particular problem. So because of that, what I would do is I would say I want to work with one side and get it to a point where it would make sense to stop and then go with the other side and get to that same point. In other words, I really want to cheat here. And I want to cheat by working with the left side and not saying it's part of my proof and then just filling in the right side after I catch up to the cheating part. And that'll make more sense as I go through it. But I want to start with this over here. It's not part of my proof. But I want to expand the left side. And if I expand that left side, I'm going to say it's going to be equal to 1 over the sine squared a over 2. And therefore, I can expand that to 1 over plus or minus 1 minus cosine a over 2, quantity squared. And I can expand that to 1 over 1 minus cosine A over 2. I can multiply by 2 over 2 here and end up with 2 over 1 minus cosine A. This is a lot easier to see than this part right here. So I really can work with the right side now, and if I can get 2 over 1 minus cosine A, I can reverse the process to getting my proof on the other side. So I'm doing this work off to the side, and I'm thinking, all right, I really want to get to here. It's just cosines. The right side, I can easily get the cosines, so this should work out pretty well. The right side is 2 over cosine A using the reciprocal identity, 1 over cosine A minus 1. I then want to multiply the top and the bottom by cosine A because I'm clearing out the fractions. By multiplying by cosine A, I'm going to see the top becomes 2, cosines cancel. The bottom becomes 1 minus cosine A, and that's exactly where I'm at with this. Well, that matches. Now I can magically get back to where I want to on the left-hand side. So I'm kind of like meeting it halfway. I know where I need to go. This isn't part of my proof, but I can say if I divided the top and bottom by 2, I would get 1 over 1 minus cosine A divided by 2. Then I could say that's the same thing as 1 over sine of A over 2 squared, which is the same thing as cosecant squared A over 2. So in a way, it's like cheating because you're not supposed to work with one side, but we had to work with one side to see where I had to go. And so that's another way to prove now, which is on your list of starting out in a certain way. The only reason why I did this again is because I looked up front and I thought to myself, how can one eventually get to the other? And I couldn't figure that out, so I had to pick one of them and go with it. This will conclude all of the concepts for the chapter. Next week we have a couple days review, and then we have the test on Wednesday and the retakes on Friday. So make sure you sign up for the retakes on that Google survey on the classroom.